CSEC Mathematics, May 2025 paper. We're at question 7. It says a sequence of figures is made up of regular pentagons, right, 5 sides, using sticks of unit length. The first 3 figures in the sequence are shown below. The vertices in each figure are marked with dots. Okay, can see that. An incomplete diagram of figure 4 of the sequence is shown below. Complete the figure 4 by adding more sticks and dots. Alright, let me just copy this part of the question and paste it over here, and then we copy this part of the question, figure 4, and let's paste it over here. Alright, in fact, since we're going to be working it out this way, let's copy it like this. Okay, good. So we can draw the next part here. So it's an incomplete diagram of figure 4. Notice now, you have figure 1. When you add figure 4, you have horizontal coming from this part, then the other sides, and this side of the new pentagon is shared with the first one. Alright, then with figure 3, you already have this side here, then you have vertical, and then the other sides. No, horizontal, I mean, it's horizontal line. So you always have a horizontal line to the right from the right upper dot. Alright, so for this one, it will be similar to this situation. You have a vertical line and this slant coming this way. It's slanted this way, and then here this way. Alright, let's put in the dots. Oh, that's there already. So there we have figure 4. Alright, good. Now, what else is going on? It says study the pattern of numbers in each row below of the table below. Each row relates to one of the figures in the sequence of figures shown on page 22. That's this page 22. Some rows have not been included in the table. Calculate the rows corresponding to 1, 2, and 3 in Roman numerals. So you must complete the rows in the table below. Okay, so let's copy the table and complete it over here. Let's drag this table down. Alright, so here we have our table. Now we have incomplete parts that you should complete. Now Let us see if we can identify any patterns of figure 1, 2, and 3. How they get the number of 6 and how they get the number of dots. And then we do that to figure 20 as a start. Okay, figure 1 to 2. Figure 1 has 5 sticks. So we have, if we start at the top, 1, 2, 3, 4, 5 sticks. Good. Let's concentrate on just sticks for now. Figure 2 has 9 sticks. So we had the original 5 sticks. And we add 1, 2, 3, 4. So each time we add just 4 sticks because 1 is shared between the new and the previous pentagon. Figure 3 has 13 sticks. That will be 9 plus 1, 2, 3, 4. So each time we add 4 sticks. So here, this would be from 5 sticks is 5 plus 4 equals 9 sticks. Okay. And this is 9 plus 4 equals 13 sticks. All right. Now, we have here, we have plus 4. For figure 1, it will be 1 plus 4 equals 5. But let's concentrate on figure 2 going on at first. Now, how can we break up these numbers here? How many sticks does figure 1 have? It's 5. So let's write the 5 here and see what we can do with it. We're saying here that this part is 5 plus 4. Can we continue with the 5? Let's see. This is 5 plus something. Suppose we multiply 4 by 2 and add it to 5. Could it be 4 times a number? Let's see. For figure 1 is just 5. Figure 2 is 5 plus 1, 2, 3, 4. For figure 3 it's 5 plus 1, 2, 3, 4. And then again you have 1, 2, 3, 4. So it's 5 plus 4 by 2, 2 times. Each time you add a polygon, you add 4 sides because you already had one side from before. So if you say this is 5 plus, let's call it 2 times 4. 2, 4 is 8. 8 and 5, 13. Okay, we're getting somewhere. So this is 5 plus 2 by 4. Then this would be 5 plus 1 by 4. Because we have only one additional pentagon. Here we have no additional pentagon, just the original. So it's 5 plus 0. But how can we put a 4 here to follow the pattern? Well, we could say 5 plus 0 by 4. Equal 5. 5 plus 1 by 4 equals 9. 5 plus 2 by 4 equals 13. Okay. So there we have that. If we should say, since we have a figure 4, suppose we did 5 plus 3 by 4. What would we get? If we follow the pattern 5 plus throughout, and then something times 4 throughout, what would happen here? Would it work? 3 4 is 12. 12, 13, 14, 15, 16, 17. Figure 4 should have 17 sticks based on this. Let's count them. Have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ah, it works. You have 17 sticks. So now, based on what happened here, for figure 20, you expect to have 20 plus, the question is what by 4? It's going to be something times 4. But what will it be times 4? Well, in this case, we have 1. Right. What we have to worry about now is this number, how to get a pattern for this number so that we can put in any figure and figure out what that number is. Interesting. Figure 1 is 0. Figure 2 is 1. Figure 3 is 2. Figure 4 is 3. Oh, so if you have a certain figure, this number that multiplied by 4 is 1 less. So what we seem to have then is 5 plus 1 less than, well, THA than figure times 4. That seems to be what we have. So it's 5 plus 1 minus 1 by 4 then. If we put the figure number here. So it's figure number minus 1 by 4. That seems to be the case. So it's 5 plus 1 less than 1 by 4. So it's 5 plus 1 minus 1, 4. This one is 5 plus 2 minus 1 is 1. So it's 2 minus 1 by 4. So for figure 1, 5 plus 1 minus 1 by 4. Figure 2, 5 plus 2 minus 1 by 4. Figure 3, 5 plus 3 minus 1 by 4. Let me rewrite this. 3 minus 1 by 4. Figure 4 plus 4 minus 1 by 4 then. I just stuck the figure 4, 1 there. But here now, if we go from figure 1, 2, 3, this would be 20 minus 1 by 4. Now what do we get for that? Let us use our calculator here. 20 minus 1 is 19. 19 times 4 gives us 76. Add 20 to that. Plus 20 equals, we get 96. 96. So based on what's happening down here, let's put this down. Figure n would be 5 plus n minus 1 by 4. Okay. So there we are with that. Alright. So figure 20. Oh my, mistake. It's 5 plus. Where did I get 20 from there? It's 5 plus the figure minus 1 by 4. My. Why did I write 20 there? My mistake. So, it's 5 plus 19 by 4 then. So 19 by 4, we have it as 76 plus, and then you have 5, add 5 to it, plus 5 gives us 81, right? So it's 81. Okay. Now, what happened here? Figure, whatever this figure this is, we don't know yet. Call it figure X. Let's say figure X. Alright, let's just write X there, and then when we find it, we change X to that number, whatever it is. Right? If that is figure X, what we know is that 5 plus the figure X minus 1 by 4 is equal to this number here, 169. Alright? So we say X minus 1 times 4 is equal to, subtract 5 from both sides, 169 minus 5. So X minus 1 by 4 is equal to 164. Alright. So there we have that. Now, we divide by 4. So X minus 1 is equal to 164 over 4, which is equal to, so we have 164 divided by 4 equal 41. Okay, so we have the 41 there. And then this would be, add 1 to both sides. X is equal to negative 1 plus 1. That's 0. And then equal 41 plus 1 equals 42. So X is 42. So X is 42 then. Alright. So there we are with that. Now the other issue that we're going to have is the number of dots. How do we get this number of dots? Let's just erase some of these workings, and then we see how we can figure out the number of dots. Alright. Number figure 1, we have 5 dots. That's 1, 2, 3, 4, 5. Figure 2, there are 8 dots. That's 1, 2, 3, 4, 5, 6, 7, 8. Figure 3, 11 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now we can see that each time we add a pentagon, we add 3 dots. So, looking at this, we're saying that we have 5 and 5 plus 3, which is 8. And then when we add figure 3, what we do is look at figure 2 and add 3 more dots. So it's 3 plus 3. So 8, if we add 8 dots, we add 8 plus 3, which is 11. But we want to form a pattern. We had the original 5 dots, then we add 1, 2, 3, and then 1, 2, 3. So we add 3 2 times. So let's look at it this way. We had the original 5 dots, then we add 2 times 3. We add 3 2 times. Alright? Now, if we look at figure 4, let's write a 4 here, then we should have had 5 plus. We would have another 3 dots. So, we would have 3 times 3, which would be 3 3s 9, 10, 11, 12, 13, 14. We should have 14 dots in figure 4 then. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright. It works. Okay. So that was figure 4. Now, here, to get a neat set of pattern, what we could do is say this is 5 plus, since we had 5 plus 2 by 3 here, we could say this is 5 plus 1 by 3, and this is 5 plus 0 by 3. Okay, good. But what we want now is a pattern where we can see the figure, the figures, number of the figure. Now here, we want to see 1 in the formula, in the pattern. 0 is 1 minus 1. So let's put it there. 1 minus 1 by 3. 1 minus 1 by 3. Okay, so that's 5 plus 0 by 3. This is 5 plus 2 minus 1, because 1 is really 2 minus 1. And I want to see the 2 in this calculation here, in this formula. So it's 5 plus 2 minus 1 by 3. So we have 5 plus 2 minus 1, 3. And then we change this formula so that we can see the 3 in it. So here, 2 is 3 minus 1. So this is 5 plus 3 minus 1 by 3. So this is 5 plus 3 minus 1, 3, equal 11. So here now, this should then be, so what we really have is 5 plus the figure number, in this case 20 minus 1 by 3, equals what? 20 minus 1 is 19. So we have 19 times 3 gives us 57, plus the 5 equals 62 then. This should be 62. Alright? Now, while we're at it, let's put in the formula, the general formula for n. This should be 5 plus n minus 1 by 3. Okay? So you see that? Now, how we deal with this now? This one. You see, to calculate this, this is figure 42. So this would be 5 plus 42 minus 1 by 3. Now 42 minus 1 is 41. 41 by 3. 3 1s 3, 3 4s 12. 123. And then 123 plus 5. So what we have is 5 and 3, 8. 1 0 2, 1 and 0 1. So this should be equal 128. So it's 128 that would come here. Alright? Of course, these rough work, you wouldn't really have the space to work them out and the table itself, you would work it towards the side. And then you put in the number alone in the table. So you have 62 here and 128 here, but you do your working out clearly. Alright? So you show all working. Alright, so that seems to be the completed table. Let us see what else is here. Write an equation in S, D, and N to show the relationship between the number of sticks S, number of dots D for figure N. Let's copy and paste this thing over here. Alright, it is right here. So just drag it down. Alright. So we have this equation. Number of sticks. Now, what we can see here is that the number of sticks, remember, this column is the number of sticks. So S is equal to 5 plus N minus 1 by 4. Alright. Number of dots D is in this column now. So we say D is equal to 5 plus N minus 1 by 3. Okay. And then, so we have S, we have D, and N. Figure N. Alright. Now, we have N in it already. How can we come up with one formula? Well, it seems as if we have 5 common to both. 5 is here and 5 is here. And we know that 5 is equal to 5. Alright? So, let's transpose each of these for 5 and equate them. Now you see all of this part. If we subtract it from both sides, what we would have is 5. Then we have equal. When we subtract this from over here, we minus it. Minus N minus 1, 4. Alright? So it goes. You see that? We subtract it. So it would go. But we subtract it from the right hand side too. So we have S minus N minus 1 by 4 equals 5. See that? So it's S minus N minus 1, 4. Let's rewrite it so we switch it around. Let me write my 5 and S carefully so that they look different. 5 is equal to S minus N minus 1 by 4. Okay, so we have our 5 there. What will happen over here now? Let me draw a line to separate them. We're going to subtract this. Alright, so let me just write it here. What we do here is subtract N minus 1, 4. And you know it's done on both sides. What we're going to do here now is subtract N minus 1, 3. And of course, you subtract it from both sides. Alright? So, if you do that, it would minus itself on the right Alright? And then you have 5 is equal to, on the left you have d minus n minus 1, 3. Let me rewrite it and make more space. So we have 5 plus n minus 1, 3 equals d. Minus n minus 1, 3. So this goes, it's gone. Minus n minus 1, 3. Okay. Let's rewrite it so that we have 5 on the left. 5 is equal to d minus n minus 1, 3. You see that? Alright. Now, as I said before, 5 is equal to 5. So if this 5 is equal to this 5, then this must be equal to this. Alright? So s minus n minus 1, 4 must be equal to d minus n minus 1, 3. And then we can simplify that. Suppose we open the brackets. We have s minus 4n. Alright, let's keep the bracket there and multiply by 4. Let's not open it yet. 4 by n minus 4, 1, 4. Okay? So they have that. That is equal to d minus 3n minus 3 1s 3. So, when you open the brackets now, remember, this is like saying s plus negative 1 times the bracket, alright? So, we're going to open the bracket. This would be like s plus negative. So it's negative. So s minus 4n, and then negative 1 times negative 4 is plus 4. Alright? Equals d minus, same argument applies here, 3n plus 3. So, what we have here now? Let's subtract d and add 3n. So we have s minus d minus 4n plus 3n plus 4 equals 3. See what happened there? Subtract d from both sides, add 3n to both sides. We still have the s and the negative 4n. Alright? We have the plus 4 equals 3. Let's arrange it so that we have only letters on the left and numbers on the right. So we have s minus d minus negative 4n plus 3n would be minus 3n. Minus, no man. Negative 4 plus 3, minus 1n, so it's minus n. Right. So, negative 4n plus that. Right. So, it is minus n equals, let's subtract 4 from both sides. 4 minus 3, 3 minus 4, that would be negative 1. Okay, that would be negative 1. Suppose we multiply both sides by negative 1 now. All the negative would become positive and the positive become negative. So you would have d plus n minus s equals 1. Okay. That's it for question 7. Alright, so we look at question 8 in our next video.